Artificial intelligence is remaking our world faster than any technology in history. From art to robotics to the very way we communicate, AI is everywhere. But every single leap forward, every question you ask ChatGPT depends on something we rarely see: energy. Behind the magic lies a massive hidden world of servers, cooling systems, and megawatts of electricity. Now, that invisible infrastructure is about to get bigger than anything humanity has ever built. NVIDIA and OpenAI have just announced the largest AI infrastructure project in history, a partnership to deploy a staggering 10 gigawatts of computing power. But this historic project raises an equally historic question. Will the future of intelligence be powered by clean energy, or will it lock us into a deeper dependence on fossil fuels? At first glance, this is an absolute engineering marvel. NVIDIA, the undisputed king of AI chips, and OpenAI, the minds behind ChatGPT, are teaming up to scale computing to a planetary level. We're talking about 10 gigawatts of AI systems. That's the same power output as 10 nuclear power plants, all dedicated to training and running the next generation of AI. They're calling it the largest technological infrastructure project ever attempted, and they might be right. But under all the hype and ambition lies a much deeper challenge. How do you sustainably power intelligence on this epic scale? The deal is monumental. NVIDIA is reportedly investing up to $100 billion into OpenAI's infrastructure, building massive data centers packed with their next-generation GPUs. The two companies will co-design hardware and software, creating a perfect fusion of AI's brain and silicon's brawn. The first gigawatt is slated to come online by 2026, powered by NVIDIA's upcoming Vera Rubin platform, which promises huge gains in efficiency. But for all its power, the announcement is suspiciously quiet on one crucial detail. Where is the energy going to come from? 10 gigawatts of continuous power is no small feat. It's comparable to the electricity needs of a major city. This kind of demand requires purpose-built data centers connected to incredibly powerful grids. The big question is, what kind of grids? Will they be running on renewables or carbon-intensive fossil fuels? Neither NVIDIA nor OpenAI has publicly committed to a specific clean energy target for this project. Their statements are full of buzzwords like scale, optimization, and co-innovation, but the word sustainability is conspicuously absent. Jensen Huang, NVIDIA's CEO, called it the biggest AI infrastructure project in history, while OpenAI focused on its goal to advance frontier AI safely. But does safe include environmental safety? In an age where AI's energy appetite is exploding, this silence is deafening. To really grasp the scale, let's break down what 10 gigawatts actually means. A single gigawatt can power about 750,000 homes. Multiply that by 10, and you're powering a medium-sized country. If this new capacity runs on traditional fossil fuels, it would pump millions of tons of CO2 into the atmosphere every year. But if it runs on renewables, it could completely redefine what sustainable computing looks like. The difference between those two futures isn't just technical, it's existential. This is why environmental analysts are watching so closely. The tech industry's data centers already consume up to 3% of the world's electricity, and that number is set to skyrocket with the AI boom. If the next big AI model requires thousands of GPUs running non-stop for months, the carbon footprint could be enormous, unless it's completely offset by clean energy. Now, NVIDIA has talked a lot about efficiency. Their new Vera Rubin architecture is designed to deliver way more performance for every watt of energy used. That's a great step, but efficiency alone isn't a magic bullet. The problem is, as hardware gets more efficient, it just makes us want to use it more. This is the paradox of AI energy use. The more efficient it gets, the more we use it, and the total energy consumption just keeps climbing. Some insiders believe clean energy is an inevitable part of the solution, not just by choice, but by necessity. You can't just build a 10-gigawatt facility anywhere. It requires massive power purchase agreements and long-term energy planning. Increasingly, major data centers are being built near renewable hubs, places with abundant solar, wind, or hydropower. OpenAI already works with Microsoft's Azure cloud, which has a goal to run on a 100% renewable electricity by 2025, so that offers a hopeful clue. But without a direct confirmation, it's just speculation. And geography is everything. Where these data centers are built will determine their environmental impact for decades. Will they choose regions like the Nordics or the American Southwest, where clean power is plentiful? Or will they opt for places with grids still dominated by fossil fuels? Every location choice is a test of their commitment to a green future. If they get this right, it could be a game changer. Imagine massive AI data centers powered by offshore wind farms, solar hydrogen hybrids, and advanced energy storage systems. Some are even looking at hydrogen fuel cells to replace dirty diesel backup generators. If NVIDIA and OpenAI embrace these innovations, they could set a new gold standard for green infrastructure. But if they don't, the environmental cost could be devastating. Each time they train a massive new model, it could have the carbon footprint of thousands of cars over their entire lifetimes. As AI becomes the new engine of the global economy, its hidden energy debt could become a massive liability unless we get it right from the start. The truth is, we just don't know yet, and this uncertainty fuels both excitement and skepticism. Optimists believe the companies will lean into renewables. Critics worry that the explosive growth of AI is simply moving too fast for the green energy transition to keep up. The reality will probably be a mix of both. But here's a fascinating twist. AI itself could be part of the solution. Machine learning is already being used to make renewable energy more efficient, predict energy demand, and stabilize power grids. The same intelligence that consumes all this power could also help us make our energy systems cleaner and smarter. If NVIDIA and OpenAI use their incredible computing power not just to build AI, but to accelerate the clean energy transition, they could offset their own footprint through their impact. In a way, AI could be both the problem and the cure. But for that to happen, we need transparency. The public, investors, and regulators deserve to know where the power is coming from. Without it, the world's biggest AI project risks becoming the world's biggest blind spot in sustainability. This is a chance for real leadership. If NVIDIA and OpenAI publicly commit to clean power, they could force the entire tech industry to follow. So, will the world's largest AI infrastructure project be powered by clean energy? We don't know yet. But the question itself will define the next decade, not just for AI, but for all of us. Because if artificial intelligence is the engine of our future, the fuel we choose to power it with will determine what kind of future we build. To explore how hydrogen, renewable energy, and intelligent systems are coming together to create a sustainable world, visit our website. Thanks for watching, and don't forget to like and subscribe for more content on the future of energy and technology.